Okay guys, welcome to a different style of video today, where the plan is to go through 10 of the hardest questions that you could face in your chemistry paper 1. We're particularly aiming these questions for level 7 to 9, and what I think you should do as you watch this video is pause it on each question, have a go, and then I'll go through the answers for each one, showing you how to get the marks. So let's start off with question 1. Here we're asked to compare, and compare is our command word. We're asked to compare the group 1 and transition metals. Well, if we start with the group 1, you guys should know that group 1 metals tend to have a low melting point and boiling point. They have very low densities, which means they actually float when we put them in water. And they're quite reactive because they react with water and they react with oxygen in the air. Now, if you were to take a look at the group 1 metal compounds, things like sodium chloride or potassium chloride, you would see that they all form these white compounds. And our final property about group 1 metals is that they all form these +1 ions. All of their ions have a +1 charge. Now, if we compare this to the transition metals, remember transition metals are in the center of the periodic table. Well, transition metals typically have a higher melting point and boiling point. Their densities are quite high. When you place a transition metal in water, it will usually sink to the bottom. The transition metals are fairly unreactive. They don't really react with air and oxygen and water. And this is why we use copper. Copper is a transition metal. This is why we use copper for pipes. Well, another property for the transition metals is that they form these colourful compounds. And you can Google some transition metal compounds and see some of the different array of colours that they produce. Transition metals are also fantastic catalysts. They speed up the rate of a chemical reaction without being used up themselves. And finally, they form ions with different charges. For example, we have Fe, which is iron. An iron can form an ion with 2 positive charges, and this is referred to as iron 2. And you can see that we use these Roman numerals. Or iron also forms the Fe3+, which would be known as iron 3. Again, we use the Roman numerals. Okay guys, looking at this answer, you don't actually have to use all of the points just to get the 6 marks. It would be enough just to use, 3 from group 1 and 3 from the transition metals in order to get the 6 marks. So I've given you more than what you need in this question. So this first question is talking about the electrolysis of solid potassium chloride. And this question is saying that electrolysis does not work. And we want to explain why. Well, the first point that we would make here is that because potassium chloride is a solid, it means that the ions cannot move. In order for electrolysis to work, the electrolyte has to have ions that can move. Now, if it's a solid, all the ions are doing is vibrating. And there's our 2 marks, that the ions cannot move and all the ions are doing are vibrating. Well, let's have a look at this next question. It says, predict the products at each electrode when the following solutions are electrolyzed. And this is a 6-mark question. So our first solution is potassium chloride, or KCl. And at the cathode, remember that the cathode is the negative electrode. At the negative electrode, we would see some bubbles or a gas being produced. And this gas would be hydrogen. The reason that hydrogen is produced is because it's a solution, and hydrogen is lower on the reactivity series than the potassium. Now at the anode, which is the positive electrode, again we would see bubbles, which is indicating a gas is being produced. And the gas that's being produced would be chlorine gas. And chlorine gas is produced because, as you can see here, we have a halide ion present in the solution. Okay, what about our next solution, sodium nitrate? Well, sodium nitrate solution again will contain our hydrogen ions, our hydroxide ions, it will contain sodium ions and nitrate ions. Now remember, at the cathode, it's the least reactive that is discharged. Hydrogen is lower on the reactivity series than sodium. Both the hydrogen ions and the sodium ions have a positive charge, but hydrogen is lower in the reactivity series, so it's discharged, and the sodium would be left in the solution. And at the anode, some people may think that you would get a nitrate gas or a nitrogen gas, and this isn't true. Whenever the halide is not present in the solution, you will still see a gas, but it would be oxygen. And you would also have some water being produced. This is our final solution, sulfuric acid, or H2SO4. Again, at the cathode, we're going to produce hydrogen gas. And again, if we look at our molecular formula for sulfuric acid, it contains no halide ions. And because sulfuric acid solution contains no halide ions, again we're going to produce oxygen gas, and we'll also produce water. Now if we look at this final question, which is worth 3 marks, it says explain why the electrolysis of sodium nitrate does not produce sodium metal and nitrogen gas. Well, remember, if there is a halide present, then you'll produce the halogen gas. But because there is no halide, we produce oxygen gas. And remember, we would also get water. So that would be 2 of our 3 marks. But we've also got to wonder, well, why are we not producing any sodium metal? And that's because sodium is more reactive. than hydrogen. So the hydrogen gets discharged instead of the sodium. And that would be our third mark. Okay guys, we're at question 3. And again, I'd like you to consider perhaps pausing this question and answering to see if you'd get the full 6 marks. This question is about sodium chloride and chlorine gas. Okay, you're asked to explain the difference in properties between sodium chloride and chlorine gas. And we're told that sodium chloride is a solid at room temperature with a high melting and boiling point, whereas chlorine is a gas at room temperature. Well, this is due to the fact that sodium chloride, or NaCl, is an ionic lattice. It's an ionic compound. And this ionic lattice has strong electrostatic forces of attraction. And what that means is that it needs lots of energy to overcome those electrostatic forces of attraction. And this explains why sodium chloride is a solid at room temperature and why it has a high melting and boiling point. Now, how do we explain the properties of chlorine? Well, chlorine is a gas at room temperature, which tells us that chlorine must be a small molecule. Now, you should know that small molecules have weak intermolecular forces. And those intermolecular forces are between other chlorine molecules. Now, these weak intermolecular forces, they don't require much energy to overcome. Now, I just want to show you guys with a question like this how you're going to score the marks. Well, you're going to get a mark here for saying that sodium chloride is an ionic lattice or an ionic compound, which means it has strong electrostatic forces of attraction. And those strong electrostatic forces of attraction need lots of energy to overcome. So you can kind of see here how exam technique plays a key part in scoring the marks. Whereas for chlorine, it's a small molecule with weak intermolecular forces, which doesn't need much energy to overcome. Okay guys, take a look at question 4. And in question 4, you're shown a table with 4 different substances. These substances are labelled as A, B, C, and D. And what you should be able to do is to look at this table, which is a very high level skill, but look at the table, look at the properties of each substance, and suggest and justify the type of bonding and substance for each of the letters. So pause the video and have a go at answering. Again, this is a 6-mark question, and then just click play and we'll go through the answers. So I'm going to start under the table and we'll start with substance A. Now, if you look at substance A, you can see that it has this massive melting and boiling point, really, really high. This tells us that it must be a giant covalent molecule. And the reason we can predict it's a giant covalent molecule is because it has this high melting point and boiling point. And the reason that giant covalent molecules have this high melting and boiling point is due to the fact that there is a large network of covalent bonds which need to be broken. Okay, what about substance B then? I'll change the colour of my pen. Let's have a look at substance B. Well, looking at substance B, we can predict that this is probably a small molecule. And the reason we can predict it's a small covalent molecule is due to the fact it has quite a low melting point and boiling point. And it would have a low melting and boiling point due to the fact it has weak intermolecular forces. Okay, let's look at substance C. Now, as you can see in substance C, that the melting and boiling point is quite high. And it also conducts electricity when a liquid or as a solution, but not when it's a solid. So that must tell us that substance C is an ionic compound. We know it's an ionic compound because it has a high melting point and boiling point. And this is due to those strong electrostatic forces of attraction. We also know that compound C must be an ionic compound because it only conducts electricity when liquid or as a solution. Because remember, when a liquid or solution, the ions can move. I think I'm going to write at the side here for substance D. And substance D is telling us that it must be metallic bonding. So this could be something like copper. And the reason for metallic bonding is that it has a high melting point and boiling point. And that would be due to, again, the strong electrostatic forces of attraction between delocalized electrons and the metal ions. But also, substance D conducts electricity. And this will be due to the delocalized electrons within the metal structure. And remember that those delocalized electrons can carry charge. Okay guys, take a look at question 5. We're now looking at some of the quantitative chemistry where a lot of students tend to have issues with the calculations and remembering how to convert from grams to moles or from moles to grams. So if we take a look at question 5, for question 5, we're asked how many atoms are there in 4 grams of calcium. Now, again, I'll ask you to pause the video, have a go at answering this question and see if your answer matches the working out when you click play. Okay, well, first things first, guys, there's an important triangle when looking at this equation. And that equation is mass, mR, and moles. So mass divided by the mR gives us the moles. So let's first of all work out the moles of calcium. So remember that moles is equal to mass over the mR. And if you are struggling with this, I've done a video on mass, mR and moles. But the mass of calcium is 4 grams. And the mR of calcium, if you look in the periodic table, you'll see that there are two numbers. And it's the larger number which gives us the mass of calcium, which would be 40. So 4 divided by 40 gives us 0.1 moles of calcium. Now remember that 1 mole of any substance contains 6.02 times 10 to the power of 23 atoms, or ions, or molecules. So if we've got 0.1 moles of calcium, we can multiply that by Avogadro's constant, which is 6.02 times 10 to the 23. That will give us the number of atoms in 4 grams of calcium. And that becomes 6.02 times 10 to the power of 22 atoms. Now you're quite lucky, you don't have to remember this number for your exam. It will be given when you need to use it. Okay guys, take a look at question 6. It's a typical question where you're expected to do something called reacting masses, but we've also got to combine this with percentage yield. So again, in this question, we're told that we're using 14 grams of nitrogen, and we're asked to calculate the actual amount of ammonia produced. Remember, this is ammonia and this is our nitrogen. We're asked to calculate the actual amount of ammonia produced from 14 grams of nitrogen when the reaction has a yield of 70%. Well, first things first, like most calculations in chemistry, let's work out the moles. And in this calculation, we can work out the moles of nitrogen. Now remember from our previous question that moles is just mass over the mR. Well, the mass is 14 grams and the mR of nitrogen, or N2, is 28. And that gives us 0.5 moles of nitrogen. Now, the second step, you have to look at the equation. And remember, we're only interested here in the nitrogen and the ammonia. And they're in the ratio of 1 to 2. can see here, look, that we have twice as much ammonia as we do nitrogen. So they are in a ratio of 1 to 2. Well, we've got 0.5 moles of nitrogen, which means we have twice the amount of moles of ammonia. So we must have 1 mole of NH3. Now the third step would be to calculate the mass of 1 mole of ammonia. Now again, if I put my triangle where mass goes at the top, moles and mR, you should be able to see that from this triangle the mass is just moles times the mR. Well, I know that I have 1 mole of ammonia, and the mR of ammonia, well, nitrogen has a mass of 14, hydrogen has a mass of 1, but there are 3 of them. So it becomes 14 plus 3, which is 17. So the mR of ammonia is 17, which means that 1 mole of ammonia has a mass of 17 grams. So this would get us 3 of the 4 marks so far. Now, if we want the 4th mark, you guys should remember that percentage yield is equal to the actual amount divided by the theoretical amount. And we have just calculated here the theoretical amount. So for us to calculate the actual amount, we would do percentage yield multiplied by theoretical. And I would divide all of that by 100 because of the percentage here. And if we put those numbers in, the percentage yield is 70. The theoretical amount is 17. 70 times 17, and then divide it by 100, it would give us 11.9 grams. Okay guys, welcome to question 7. I think I've made the text a little bit too big in this one because it's cut off the 3 mark, but the process is what's important here. So don't judge me too much for the text. So if we look at question 7, this question is asking you to calculate the volume of 120 grams of carbon dioxide. They want you to give the volume in centimeters cubed, but also to give your answer in standard form. And we're told here, a bit of a clue actually for this question, that 1 mole of any gas has a volume of 24 decimeters. It's just important to point out at this time that this question will only be relevant for those of you doing the single science. Combined science, you're okay, skip to the next question. So, pause the video, have a go at answering it. Remember, this is a level 7 to 9 question. But if you think about the steps we've put in place in our previous questions, you can at least work out the number of moles. Okay, so with this question, the first thing that we would do is just to work out the number of moles of carbon dioxide. We've been given its mass, and you should remember the equation that's mass over mR, and that gives you moles. So if you look at the periodic table, you will notice that carbon has a relative atomic mass of 12, and oxygen has a relative atomic mass of 16, but there are two of them. So that means carbon dioxide has an MR of 44. So to work out the moles, we would do 124 grams divided by 44. And that gives us 2.8 moles of carbon dioxide. Now remember that 1 mole of a gas has a volume of 24 decimeters cubed. So 2.8 moles of a gas would have the volume 67.6 decimeters cubed. Now if you got this far, this would be worth 1 mark. But we've now got to convert our answer into centimeters cubed. Now remember that 1 decimeter cubed is equal to 1,000 centimeters cubed. So we've got to multiply our answer by 1,000, and that gives us our answer in standard form, that is 6.7636 times 10 to the power 4 centimeters cubed. This would be your answer. Again, guys, if you want me to make a video on how to do standard form, please let me know. It's not a problem to put these videos together at all. Okay, guys, I hope you're not getting bored with me at the moment, but it's really good practice for you guys to have a go at these questions. The more confident, the more comfortable you become with these questions, the better you'll do in your exams. So take a look at question 8. Question 8 tells us that iron reacts with bromine to make iron bromide when heated strongly. I'm going to ask you to pause the video and have a go at these 3 questions. You've got to complete some half equations and then look at the next 2 questions and then hit play when you're ready to go through the answers. So for this first one, we've got to look at this half equation, and we realize that there must have been Fe on the left-hand side of the arrow, and the iron has been oxidized to Fe3+. So the iron must have lost electrons. Now remember that the charges on both sides should balance. So to turn Fe into Fe3+, it must have lost 3 electrons. Now, in a redox reaction, we have something here that has been oxidized, and that just means it's lost electrons. Well, if something's oxidized, the other species must be reduced. Remember that reduction is the gain of electrons. So here we could show that bromine turns into bromide ions by gaining an electron. But this equation isn't balanced because we've got two bromine atoms over here. We need two bromide ions, and again we're going to need two electrons to turn these bromine atoms into ions. So that would be your 2 marks. Okay, look at question 2. It says, how might the reaction be different if it were iron and chlorine? Well, when we look at group 7, remember that fluorine's at the top, then you've got chlorine, then you've got bromine, and then you have iodine. And the reactivity decreases as you go down group 7. And it says, how might the reaction be different if it were iron and chlorine? Well, the reaction would be faster. The reason the reaction would be faster is that chlorine is higher up in the group than bromine, which means that chlorine is more reactive. And that's why the reaction would be faster. Okay, this final question says, why does iron form FeCl3 and FeCl2 when it reacts with chlorine, but sodium only forms NaCl? Well, remember that Fe is a transition metal. And earlier on in our, I think it was question 1, we said that transition metals form ions with different charges. Whereas sodium is in group 1 and it only forms a +1 ion. Okay, take a look at question 9, guys. A student is reacting zinc with aqueous solution of iron chloride to produce zinc chloride and iron. And we're asked here to write an ionic equation for this reaction. So basically turn this equation into a redox equation. So we've got our zinc and we have our iron, and we also have our 2 chloride ions. Now remember that chloride ions always have a single negative charge because they gain electrons. Now if we've got 2 negative chloride ions, then our Fe must have been Fe2+, because there isn't a charge on the compound. And that forms zinc chloride. Remember, look, chloride has a negative charge, and our zinc again must have a 2+ charge to cancel out the 2 negative charges over here. And that would be plus Fe. Now, this is the easy part. All you guys have to do is cross out the ion or cross out the spectator ion that doesn't change before and after the reaction. And hopefully you guys can see that that's the chloride ion. It has not changed during this reaction. So all we do now to write our ionic equation is we write the whole thing out, but just missing out the chloride ions. So the ionic equation becomes Zn plus Fe2+ to make Zn2+ plus Fe. And again, if you want some more examples of ionic equations, just let me know in the comments, and I can sort those out for you straight away. The final question here says, a student repeated the experiment with gold instead of zinc. State whether a reaction occurred or not and explain your answer. Well, to answer this question, you've got to think about gold's position on the reactivity series. And gold is very low down on the reactivity series. It's not very reactive at all. So that probably means that no reaction would take place. And the reason for that is that gold is unreactive. So we get 1 mark for no reaction and another mark for explaining our answer. Okay guys, we're at question 10. This is our last one. Let me know if 10 questions work as well. I can always do videos with just 5 questions if this was a bit too long, but I want to give you guys as much practice as possible. So take a look at question 10, and it says that hydrogen and bromine react together in the following way. Here's our hydrogen, here's our bromine, and they react together to make hydrogen bromide. Now this reaction has an energy change of minus 108 kilojoules per mole. So that lets me know that this must be an exothermic reaction because energy is being released. And we're asked to calculate the bond energy of the Br-Br bond, or the bromine-bromine bond. And here we're given the hydrogen-bromide bond energy and the hydrogen bond energy. Well, you should know that the energy change of a reaction is equal to the energy required to break bonds. And remember that breaking bonds is endothermic, so energy is put in to break bonds. And that is minus the energy released when bonds are formed. Forming bonds is exothermic, meaning that energy is released or given out. Now, we're told that the energy change for this reaction is minus 108 kilojoules per mole. And that is equal to the bonds that we're breaking, which is the hydrogen bond and the bromine bond. And we take away from that 2 of the hydrogen bromide bonds. And now we can start to substitute the numbers in, because we're told here that the bond energy of hydrogen is 436 plus X, because we don't know the bond energy for our bromine bond. And when we do our calculation here, 2 times 368, we get 736. So this just becomes minus 736. And we've got to do a bit of algebra to find out the value of X. So the first bit of algebra to do would be to get rid of this minus 736. And to get rid of this minus 736, we can plus 736 on this side, which means we have to plus 736 on this side. And that would give us 6 to 8 being equal to 436 plus x. Now to find the value of x, we just do 6 to 8 minus 436. And if you was to type that into your calculator, you would get 192 kilojoules per mole. And this would be the bond energy of our bromine molecule. Guys, let me know what you thought of this video. It's a different style of video, but like I said, I've had a few comments of people asking me to do booster questions and questions to support them in their learning. So let me know how you found it. I'm looking to do some physics ones and biology ones. Again, let me know if there's anything you want me to go through. All right, guys, ultimate learning.